So this is the question where we have to since print the longest common subsequence there. Okay, so now before this video I have to explain if we have to simply written what's the length of the longest common subsequence, if I'm talking about this lead code question. I explained this in my previous video where I explained this how to return this length of the LCS there in the question in which. So this is the continuation of that video there. There's nothing but the here in this question we have to just print that there are the multiple possible LCS are the for the string s1 and s2. So for which we have to simply return any of the LCS string there. So now continuation of the previous video, I firstly suggest you that you should see the previous video for how to find the length of the LCS. And then now, so after I think you have to check that my video. So now coming to this video, here we have to just print that video. So since for the print LCS, we see in my previous video we have to go for the brute force, then we have to optimize that by using the memoization version. Okay, so that are the crucial for the finding the length there. But now for the printing there, we should see how the backtracking goes on in this question there, and how this DP works there. So let's summarize this question again. At every position in the both of the strings, we have the two things there. Either if the characters match, so we have to include that character and move the diagonally there, and if they not match, so we have to move in direction of larger DP value. What I'm trying to say, let's say there's a two strings given there, s1 and s2 given there. So we have to associate the pointers with these strings there. I have to point I with a string s1 and j pointer is to for the s2 string there. So there's the two condition, if the characters match or not. So in the case of match, we have to since include that and move both of the pointers there. And in the case if both characters doesn't match there, so we have two choices. Either we have to skip from s1, means at one time we have to move this i1, and another time we have to move this i2, and whatever the maximum we have to since include that part also into it. So this is my definition of f of I comma j, and this is the both condition. So I explained this in very well in my previous video, where I have also explained the dry run of this question for this test case where s1 and s2 are given in here. Now since for printing this LCS, we had to go for the tabulation method, where I have to where we see how this actually backtracking works goes on. So for this, first of all I have to take one of the bigger test case there to understand very well. So now come to the let's what's given in the our s1 and s2 there. So s1 is nothing but this is the a, b and c, then d, then e. So this is our s1, and what's the s2 here? So s2 is nothing but the b, then d, g, then e, then k. Okay, so this is the question there. These are the two strings there, and explain here very again, these are the states. There's the definition of states which I define for using the recursion purpose there. And since I have to know very well if we have to draw the whole of the recursion tree there, so we see since one of the many of the states are repeated, to avoid that recomputation, or we can say to avoid that again and again solving for multiple states there, we simply store that values. And if they are occurring again and again, we simply using our stored value. So for the storing value, we have to simply use our dp vector there. So that's why we go for the dp. And since we go for dp, so I can write there what we need there. We simply this is the simply meaning of the dp of j of I of j. So it is similar whatever the meaning of this f of I comma j, this is nothing but the same as I can again write this. This is nothing but the length of the LCS of I can say of s1 there, of s1, and where what it mean of s1, it is goes to the s of 0 to I can say 0 to I index there. And similar this is goes on for the s2 string there to its index j there. Okay, wait a second, this is for the j minus 1 there. Since this is simply but the length there, so that's why using the I minus 1 and j minus 1 there. Okay, so these are the meaning of the this dp of I and j there. So what we need to find there, we simply need to find simply the dp of n and dp of m. Like you might be confused, like why we are using this n m, why we are not using the n minus 1 or m minus 1, because like I have to say here why we don't use n minus 1 there, and like why n minus 1 there, so why it doesn't goes there. So we don't use this because in the recursion method or in the memorization method, so when we write the base case for this question, so there's a I less than 0 and j less than 0. So this is nothing but the means whenever there's a case arise when i's become the minus 1 or j's become minus 1, so simply we have to return the value 0. But in our dp value we don't have to store this value, like if we are trying to storing this value here, dp of minus 1, we can say minus 1, let's say, and there's a something and another value there. So this is like nothing, this is not possible for these questions. So to handle this negative, avoid to these negative cases, we simply shift our, we can say simply shift our index by 1 unit to avoid storing negative in dp table. So that's why we are using the dp of n and the m there. Okay, so now this is the, and like since again we can write for this dp means what we have to do, this dp is nothing but the, I can write there, this dp is nothing but the dp of ij is equal to 1 plus dp of I minus 1 there, and thus j minus 1 there. This is for the case if I can say that my character has matched there. Okay, and like this is for this case there, and you have to go for, I think we should write, like cover this part. Okay, so this is for this path, and if the characters doesn't match there, so in that condition we simply use the dp of I comma j there, and this is nothing but the max of dp of at a time we have to move only I there, and another time we have to simply move our j there. So these are the two cases, and what are the maximum, this is accountable for the case if I can say this is for the if not character match there. Okay, whenever I am talking about the character, so it means whenever I have to stand at any of the characters, so I am representing that character only. So if I have to stand starting from this I and j is from this, so what it means, we simply use the I for this and I simply use the j for this. Okay, so like for you I made this dp table, so this nothing but the, this is for the I there, this is for the j there. In our previous questions we know very well, like when we use the our memorization version there, I again prefer you that you should see my previous video for explaining this part. So before printing you must know, like it would be beneficial for you to know the video about like how to print or how to return the length of the LCS there. So in whenever we have to talking about the memorization version, we use our dp table, and that dp table is of the n comma n into m there. So that's why this is of our dp of n into m table there. Okay, so this is our s1 string, this is our s2 string, and this is the filling of, like whenever let's say if I'm talking about this 3, so this is nothing but it means till this index I and till this index j, the length of the longest common sequence is 3. So that means if I have to stand at there, so what it means, till there our b, d and e, and here again BDE. So three words are overlapping, or we can say we are able to find the maximum longest common subsequences length is 3. Again you can find for this to this one. So okay, so this is now nothing but the our printing our DP table here. So now see how to do this. So we see one thing here, like what we have to say. So first of all, we have to build this DP table. Now we have to start from this DP of use this pen there. So we have to start from this DP of, wait a second, okay, so this is our DP of n of m there. Okay, so I can say how we do traversing this. So we can say one thing, in if the case of the matching there, we have to take that character and move to diagonally, means we have to I of j, so we have to take that character, means it become 1 plus, because this is accounted in our answer there, and we have to move to I minus 1 j minus 1. So what it means, our row is decreasing by 1 and our column is decreasing by 1. So simply it means we have to move the diagonally there. Okay, so now we have to come to this part here. Okay, so this is the meaning. But like wait a second, this is for the case if we have two matching, but like we do is mistake here. This is the K, this is E, so like I do mistake here. Okay, okay, so this is the case if the character matching there, and if the character doesn't match there, so in that direction we have to simply go to the larger value. So if we have to start from this value there, and since here the character is E and here the character is K, so they are doesn't matching there. So in that case we have to follow this second case there. So now we have to go to the maximum value. So if we have to go to this 3, so what it means, this is nothing but this is achieved by decreasing the j by 1 unit. And again if we have to go for this, so this is achieved by decreasing unit I by 1 unit. Okay, so we have to since we have to go for the maximum value, so that's why we have to go for this. So by this we have to come to this value. So this is nothing but the like how we do this. So this is nothing but we simply decreasing our j there, and that's why we go to this again. Okay, now we have to arrange. Now we can say we have arrived at that position whenever our E and E are matches there. So in that condition we should follow our case 1. So in that case we should move our diagonally character, means I minus 1 j minus 1. So in that condition our I minus minus and j minus minus, so both are decreasing simultaneously. So by this we have to arrive at this situation. So similarly like this DPs goes on like don't need to describe all over this. This path goes on there. Okay, so that's why this is our code. First of all, here I have to make our DP table. So here I have to made our DP of n plus 1 into n plus 1 there to handle our all of the base cases there, all of the edge cases there, so that it doesn't exceed our all of the cases. And now we have to traverse from I is equal to 1 to n. So this is nothing but the I is equal to 0, 1 and to this n there. Like if I'm saying about this, what's the n is nothing but the length of our s1 string, and there's a s1 string is this a b c d e, so this is nothing but the 5 there, so that's why 5. And like if I'm saying about this is nothing but the length of s1 string, and the length of the s2 string is again the 5 there, that is b d g e k. Okay, so the dp length is we are using here is n plus 1, I can say there, and again the n plus 1 there. So what it means, so it simply means dp of 6 there, I can say the 6 there, and again the 6 there. Okay, so this is our dp vector here, that's why you can see the like 6 rows 6 columns here. So here we simply used our iteration is 1 to n there, means it goes to 1 to n, again j is goes to 1 to m there. We don't need to worry about these 0 cases there. Okay, so if now we have to see if our s1 is s1 of I minus 1 and s2 is j of minus 1, means this means s1 of I minus 1 and j of I minus 1. So if these characters are matching, so what we do simply we know very well, we have to again write it like dp I j is equal to nothing but the 1 plus dp of I minus 1 j minus 1. And in the else condition, means characters are not matching, we have to take only the whatever the maximum value there. So this is the process we have to build. We have build our DP table there. We can say build DP table here. Okay, now since in this question it is requirement to print the LCS, so for the printing side this, now how to print this, like since here to we have to traverse our I and j, and now it is starting from this value and now it reaches to the starting value. So again, first of all we again initialize it with our n and j, I and j with n and m, like starting again I with n there, and j means we have to point our I and j here to starting here on. Now see, try to print it all over the DP table. So how to do it? So we can say one thing there, while our I is positive and j is positive, means if we have to start our I and j from here and it goes according to our pathway and reaching to here, it either be possible that it can exceed to through this boundary or to this boundary or to reaching here. So in if it exceeding any of the boundary, so that's why we are using the AND operator. So if whenever if is greater than 0 and j is greater than 0, so in both uh, this goes on whenever I is greater than 0 and j is greater than 0, and this is the case for the I minus 1 j minus 1. So if in match case we simply add our result plus is equal to that character there, so it doesn't matter, we can use s1 or s2, both are, since both are same there. And in that case we simply like after counting this we usually minus our I and j and now come to our another cell there. Okay, this is the case of matching, and this is case of the non-matching. So in the case of non-matching we have to see whether this value greater than or this value greater than. So if we have to see where let's say we are standing at this I comma j position there. Okay, so like and if I have to call for this, so what it means, this is nothing but the 0 1 2 3 0 1 2 3 4 5. So this is nothing but the i's and j is nothing but the 5 there. Okay, so this is the coordinate for this I can say. Okay, I have used to this. Okay, so this is the coordinate for this. Okay, now since there's a character doesn't matching, so either it goes to it or either it goes to it. So what are the value possible or what are the value possible for it? So if I have to point it, okay, and if I have to point it, so what are the coordinate for this? So I can say here, so what is the pointer for it? So here I is decreasing, so that's why our I is nothing but become the 4 there, and our j is remaining the same there, that is nothing but the 5 there. Okay, so this is the coordinate for this cell, and if I'm talking about first of all I can erase that point there. Let's erase that part here. Okay, now call for it. If I have to come to this part, so there's nothing but the our I is remaining the same here, that is the 5 there, and our j is become the 4 there. Okay, so that is the coordinate if I have to start from it. Okay, so this is nothing but the if our I minus 1 of j is greater than I of j minus 1. So what it means, I minus 1 mean I'm talking about this cell, means upper cell. So if our upper cell is value is greater than its left cell value, this is of left cell value, this is upper cell value. So whoever is if our upper cell is value is greater than, so we simply use that value and simply do our I minus minus there. Okay, so we do I minus minus there. And why we don't use don't add this in our answer, because this is not matching condition, so we don't worry about that condition. We only want the overlapping, or we can say the matching characters only, so that's why. So but here the left is greater than, so it goes in this direction, so means j minus minus, so simply j become this. Okay, so this loop goes on till it doesn't exceed any of the boundary, and you know very well, like if it exit any of the boundary, so we also see like in if any of the I and j becomes the minus 1 in the recursive direction, recursive solution. So similarly in this question, if our I becomes 0 or j becomes 0, so that means we are not able to find any more of the common subsequence there. Okay, so like I'm using for it. So initially I'm standing at here position, and since these are the node matching condition there, this is the E and this is a K. Let's say whatever the variable I'm using here, so I'm using the result here. Okay, so this is initially result is string, and initially it is empty, we have to start from it. Not matching, okay, now goes to greater value, okay, so it means now it is a matching condition, so we simply include this. Okay, we can do this, so we use the E there. Okay, and like now goes to the upper and left, and since both are the values, so it doesn't matter. Let's say we go to the since this is the same, so we moves the diagonally there. Okay, now see, this is G, this is D, so moves to greater value, so 2 comes to this value. Let's say I can use this there, so I'm coming to this value there. Okay, and like if I'm coming to this value, and since D and D, these are the same, so that's why I have to add this in our sub. So I have to add this by doing this. I think this is showing me overlapping conditions, so that's why I need to erase it and do again this. Okay, like I've let's say, okay, first of all I explain you, and then after it I have to like how to. Okay, so since this D and D condition are saming, so it goes to diagonally, so it goes to here. Okay, and now again there's a C and P, these are the node, so either in this direction, either in this direction, doesn't matter there. So let's say it goes to this direction, so here it, if it arrive at this position, now these are the same here again, it moves diagonally there, and now it becomes, since I become the 0 there, so means it goes to this loop, exit this loop there. Okay, so if I have to write this in our result case there, so this is nothing but the, our result is nothing but the, in first I have to counter this E there, I can use there, and then after it we have to add this D there, then after it we have to add this B there. Okay, but like if you have to see, these are, this is just opposite for this case, like here it should be the BDE, but it is EDB, so that's why we have to reverse it, we can say this, reverse it. Okay, so that's why we have to reverse it and simply return that result. So that's our the question there, and like this is the simple. If you face any kind of difficulty, so you can watch it again and again. I think it should be clear in the first approach there. And what's now discussing about the time complexity for this question there, so this is nothing but the n into m there. Okay, and what's the time space complexity is again the n into m there. Okay, so this is the final question there. So since the problem asks for the to the print LCS, so like I directly use the tabulation method to build the DB table, and then backtrack from DB of nm to m to reconstruct the subsequence, or I can say the sequence, whatever the required in our question. So thank you.